She wants her discount rate. The value of money in the future should be decided partly by interest rates. Here's another way of doing this. This is what we're going to be doing on the worksheet. Instead of asking how much could $10 be worth in 10 years, we could say how much is $100 worth today. And we're going to use a formula. This is the present value formula. And it's going to tell us that $100 in 10 years is worth about $68 today, just far more than $10 today.
Okay, you've got the undercoating, clear coating, rust proofing, underguard spray, gravel guard XJ, Vitaseal repels it. But if you want to protect the paint, you better keep it in this tent.
Will do.
Okay, here's how your lease breaks down. This is your down payment, then here's your monthly, and there's your weekly.
And that's it, right?
Yep. Oh, then after your final monthly payment, there's the routine CBP or crippling balloon payment.
But that's not for a while, right?
Right.
Sweet.
Well, these balloon payments are something you never want, maybe should be illegal. It tricks people. It tells them, well, you can have this car today, and you're going to have really low monthly payments, but in 10 years you're going to have a huge payment, maybe like 20% of the value of the car. And people look at that balloon payment, they say, well, it's not a long ways from now, so what do I care? But if you want to be smart, and you're getting that offer, you say, how much is that balloon payment in the future? And then you use this present value formula to determine what's that like today. And so this is how we'll look at it. Balloon payment, a one-time large payment made on a loan, usually many years from when the loan is made. If the crippling balloon payment is $10,000 in 12 years, what is that amount in today's value? Assume a 4% discount rate. What I do is I use this present value formula that we're going to learn. I say $10,000, interest rate is 4%. I have to pay it 12 years from now. Today, that $10,000 is equivalent to about $6,200. So that's like me making a payment today of $6,200. Why? Because if I took $6,200 now, put it in the bank, let it earn 4% interest for 12 years, after 12 years, I'd pull it out of the bank and I could make that $10,000 balloon payment. Thank you. Now I'm going to go through the worksheet. The first part, part A, is stuff you probably already know, but I've got to make sure you understand the simplest things before I get to the rest of that. And again, anybody need a worksheet? Anybody come in late? Yeah, I'll get one to the worksheet has some formulas at the top. We're going to throw out those that work out for now. First, looking at A, which is just about compound interest. We're going to start with a really simple example. So suppose you have $70,000. You invest $70,000 for 1 year at a 3% interest rate. How much will you have after 1 year? Well, you just say we're investing $70,000 for 1 year at 3% interest. So after 1 year, we get $70,000 back. That's why we multiply it by 1. Plus, we get 3% of $70,000, 3% interest. I'm going to, probably in the future, most of the time, instead of writing 1.03, just put 1.03. $72,100. In a little bit, once we start doing exponents, some of you don't really know how to do exponents in your calculator, so I'm going to go slow. I encourage you to do the calculations with me. I'm going to go to my calculator, redo it myself just to make sure I give you enough time. And if you're not getting the same answers I am, either I'm wrong or you're doing your exponents wrong. Come see me after class and we'll get it straight. Now for 8.2, watch me derive this formula. And don't write anything down yet. I don't think you need it. What we do now at 8.2 is saying, well, it's still $70,000. You still earn 3% interest, but now you're earning 3% interest every year. So you start off the same. Again, I wouldn't write this down. I'll continue to. What I'm doing is deriving this formula FD equals PD times 1 plus I raised to 2. After the first year that you invest the money, you have this amount of money. Now we got up here. But then we're doing this for 10 years. And so after the first year, you take all the money you made and you put it right back into earning interest. And how much money do you have after 2 years? Well, it's that amount times 1.3. That's the second year. The third year, you do it even again. You take all the money that you've made, you put it in the bank, earn 3% interest, and the amount of money you have after 3 years is all this times 1.3. So you can see where we're going. It's been 3 years. We multiply this thing times by 1.03, 1, 2, 3 times. So we go 4, 5, 6, 7, 8, 9, 10. And the reason you learn exponents is so you can take this big long thing and do this. Can you do that? 94,000. That's why we have that formula at the top. The future value, the amount of money you have after a number of years, equals the present value, the initial investment here, $70,000, times 1 plus I, 1 plus the interest rate, 1.03, raised to T. T is the number of years you keep your money in this investment. And that one formula, FD equals all that stuff up there, everything in finance goes from that one formula. That one formula drops everything. Now A3, as it says now, the same amount of money, $70,000, but it's at 6% interest rate for 10 years. How much money will we have? Well, we've got $70,000. Interest rate is 6%, so I'll multiply it by 1.06, just raised to 10 again. And of course, it's earning a double the interest rate, so you get a lot more money. Again, I'm redoing them myself to make sure you have enough time to do these calculations. Larger interest rate, you get a lot more money, which is why if you're going to have your money in an investment for 10 years, probably better to have it in something like stocks that have a much higher rate of return. I'm going to write A4 and A5, write the answers in the for A4, so now it's $70,000 at 6% for 20 years. Have your money in a much longer period of time, you get a lot more money when you pull it out. And A5, let's go do present value. Let me hold on. Be good? For A5, it's a little different. Now it says, instead of investing money now, how much will we have in the future? We say, in the future, specifically 20 years from now, I want to have access to $1 million. If the interest rate is 7%, how much money do I need to invest today such that after 20 years I'll have that $1 million? This is like planning for retirement. If you want $2 million to retire on, how much you need to have, start saving now, that kind of problem. And what I'm about to derive the present value formula, you don't need to look at the steps. I'll tell you when we get to the equation that gives you the answer. Let me rewrite the future value equation. This is what we've been doing. The future value, the amount of money in the future equals the present value, the amount we put in today, times 1 plus interest rate, raised to T, the number of years the money is in the bank. But A5 doesn't want the present value. It tells us the present value. A5 is saying we want $1 million here. What does PV have to be? Well, if we just solve this equation for PV, we get this. Present value equals the future value times 1 plus I raised to the negative T. Some people don't like negative exponents. This is the same thing as saying this. So for A5, the present value, the amount we need to put in the bank now, equals the future value of $1 million. And our interest rate is 7%. And it's over 20 years, so my exponent is negative 20. Present value is $258,419. If you want to check yourself, you can say, what if I put $258,419 in the bank right now, that earns 7% interest 20 years, what's the future value? Should be $1 million. Okay, now for B. Now we've learned present value. Let's start applying it to rather simple problems, but problems that are representative of virtually every investment problem that companies and households face. B1 says you have the opportunity to spend $50,000 today. And you pay the money, and it'll be worth $80,000 in 10 years. And you want to say, is that a good investment or not? Well, it depends on what your alternatives are. And in all these problems, I'm going to be saying your alternative to buying this investment is investing it at a certain interest rate that I give you, but if you're in the real world, you look at the rate of return you get with other things, like with a bank or a bond. what I tell you here is, and B.1 is asking what's the opportunity cost of investment. It says answer that by assuming you can invest money at a low interest rate of 4%. And it's saying instead of buying that investment now for $50, that'll give you $80,000 in 10 years. What's the opportunity cost? Instead, suppose you take the $50,000, invest it at 4% interest for 10 years. How much money will you have in 10 years? What does that say about the profitability of that investment? The B1 tells you an investment, but it says how much could you make in your next best alternative? That's the way to determine if this is a good investment or not. So we say, what if instead, we're going back to future value real quick, instead of buying an investment, you took $50,000 and you invested it at 4% interest rate for 10 years. How much would it give you? And that's the number I come up with. So if you didn't do this investment, your next best alternative in 10 years will give you $74,000. Does that mean this investment, not this one, but the one where you pay $50,000 now and you get $80,000 in 10 years, is that a good investment or a bad investment? Good, because it makes more money than this. This is how finance works. You say, this is an investment, let me compare it to my next best alternative, pick the one that makes the most money. You don't need to write all this out, but just watch what I'm writing and you'll figure out what to put on your notes. What this means is the investment that costs $50,000 now and pays $80,000 in 10 years is a profitable investment. Profitable always meaning not does it make money, but does it make more money than your best alternative. Opportunity cost of $74,000 means this other investment is more profitable. It's a good investment and you should do it better than the alternative. Kind of like if you own a stock and that stock has a 1% rate of return 1 year, so the value of the stock goes up 1%. At first you want to say, well, that's good. I'm wealthier now. But it's almost anything gives a rate of return better than 1%. If you get 1%, you say that's just poor. I could do better than 1% in almost any other investment. Doesn't matter what it makes money, but it makes more money than the alternative. And I wouldn't ask you this, but if you're wondering what do companies, what interest rate do they use, they'll use something they often call a risk-free rate. Meaning they'll say, what's the highest rate of return I can get on an investment that is going to actually give me that rate of return with almost certainty, like a government bond or a bond in a very, very safe company, something like that. But it's always up to the company what interest rate they choose as the alternative. Now here's the other way of answering B1. Now let's say, well, this investment pays $80,000 in 10 years. Is that worth $50,000 today? Let's take the present value of $80,000 in 10 years and say, is that bigger or smaller than $50,000 today? what we do is we use the present value formula. Present value. And here is the formula you write in there. I know you don't have much room here, but that's because most of these you just need one little line. This investment pays us, the future value is $80,000. The interest rate, the next best alternative is 4%. And it pays off in 10 years. I get 54,045. So this investment costs $50,000. How much is the investment worth? Its present value today is $54,000. Now, would you be willing to give me $50,000 if I gave you $54,000 in return? Yes, that's what this investment is. No muscle shirt today. What's going on? I still notice your t-shirts don't quite fit though. You want to make a little collection?
Yeah, I haven't bought shirts in about 3 years.
Yeah, I'm sure that's the reason.
I'm sure some people don't complain.
B3 is just a multiple choice. The answer is A. That question is just trying to summarize what we've been doing thus far. Now, B4, what I've tried to do there is recreate a simplified form of the refinancing dilemma that my wife and I faced. Remember what it was? We had to pay about $3,000 to refinance our mortgage in return for savings in the first year, second year, up to the 15th year. Is it worth it? And this is what we did. And this is my simplified version of it. It's an investment. It costs money today. This particular one costs $200,000 today. You think of it buying a factory. Just working on $200,000 today. This thing pays off money every year for 3 years. In 1 year, it'll make you $80,000. In 2 years, it'll make you another $80,000. In 3 years, it'll make you another $80,000. So you're paying money today in return for money down the road in different lump sums in different years. Just like the refinance had to pay money today and had savings the first year, second year, and third year. Now the problem with this, you don't want to just add 80,000 plus 80,000 plus 80,000 because you cannot compare a dollar next year to a dollar today. You cannot compare a dollar in 2 years to a dollar today. And you certainly cannot compare a dollar in 3 years to a dollar today. But you do want to put all these on some kind of comparable units. You want to compare apples to apples. And that's what that present value formula does. What we're going to do is we're going to go into that table and convert every dollar in the future to its present value equivalent. Then we can just add it. So in our table today, called $200,000, the present value of $200,000 today is $200,000 because it's today. So in the fourth column, in the row for today, the number you want to put is negative $200,000 because we're spending $200,000 in present value terms in today's dollars. And now we're looking at the money that comes in. In the first year, meaning after a year, we get $80,000, but what's the present value of it? Present value of $80,000. The interest rate is 4%, meaning if we did not buy this factory or whatever it is, we would just invest our money and let it earn 4%. And that $80,000 is 1 year from now, so we discount it as 1 year. That. $76,000, 923. $80,000 in 1 year is worth $76,000, or about $77,000 today. And I think you see where I'm going with this. Year 2, year 3. Each case would take in present value $80,000. Interest rate is 4%. This sum, that $80,000, we don't get until 2 years from now. Discount by 2. This $80,000 we don't get until 3 years from now, so we discount that by 3. We always want to look at the profitability, something which we always think of in terms of revenue minus cost. Our cost here, do this. Profits equal revenue minus cost. Now here we have those revenues of $80,000, but we'll put everything in terms of present value, what they're worth today. Our profits here, my revenues, I'm first going to do $76,923.80 plus revenue 2 years from now. And notice the same amount of money is worth less today the longer we have to wait to get it. $80,000 in 1 year is worth $77,000, but $80 in 3 years is worth only $71,000. Those are revenues minus the cost of $200,000, and I get this thing makes you profits of $22,000, $22,007.29. Those are profits in today's dollars. It's taken into account opportunity cost, because it was built in when we did this discount. And is it profitable? Absolutely. That's a positive number. So this thing is profitable. We would make more money doing this than we would if we just put $200,000 and let it earn 4% interest if we want. We're done. If you need help with your calculator doing this, please come see me